Morning and welcome to the Monoxivent webinar series. My name is Ian Frank and I'm a Vice President at Monoxivent. Today's presentation will focus on Monoxivent's UnderDuct products and displacement ventilation. Our presenter is Brian Phipps. Brian is an engineer at Monoxivent and has been with the company since February of 2012. Also with us is Sam Stelzner, who's also an engineer in our fiberglass division. A bit of housekeeping for today's webinar. In the lower left corner of your screen, we are encouraging participants to text questions to us. We'll read back the questions and answer throughout in an effort to encourage dialogue during the presentation. Monoxivent's fiberglass products include UnderDuct, which is our plan and spec HVAC type duct, and our corrosion composites, which is more industrial and custom applications. And without further ado, we will go ahead and turn over the presentation to Brian.
Thank you, Ian. We're going to start off today's presentation by going into the basics of a traditional mixed air ventilation system. Then we'll move on to a displacement ventilation system. And finally, we'll wrap up with how UnderDuct and Monoxivent tackles the challenges of a modern displacement ventilation system. On this first slide, we have a picture of a standard mixed air ventilation system, and a mixed air ventilation system is characterized by the supply duct as well as the return duct being located at a high elevation as shown in this picture. This means that the supplied air has to come in at a cooler and higher velocity so that it can stir the entire contents of the room, creating a homogeneous temperature and solution. And then on the other end of the room, we see the return air system that exhausts the air out of the room. Let's start off by looking at a mixed air velocity profile. Now, what this demonstrates to us is a room where the air is being blown in at a high velocity, shown here at the top. And you can see these two columns represent people. You know, it's kind of a stretch, but they're about 6 foot tall. So we're looking at a room that's maybe 12 or 14 foot ceiling. Now the red area here in orange and yellow characterizes a high air velocity. What this means is that this person will likely feel drafts and much colder than anyone else in the room. Whereas this person over here is surrounded more by a light blue color, signifying slower air movement or maybe even no noticeable air movement. Well, that means this person is hardly going to feel any of the air-conditioned air at all and might feel a little stuffy. Here we have a temperature profile in the same room, and you can see because of the high velocity coming out of the top and then the return air also being from the top, we've mixed the entire air contents so that from floor to ceiling, the air is roughly 74 degrees or so. It's the same temperature throughout. With displacement ventilation, instead of having the supply ductwork at a high elevation along with the return, we're going to move that supply ductwork closer to the ground as shown here. It may be built into a wall like so, or it may be coming out of the floor somewhere in the room. We're going to move the air in at a slightly warmer and slower rate, so as the people, electronics, or anything that generates a cooling load in the room will warm the air through convection. And as that air warms, it's going to rise to the top, and then the hot air will be exhausted through the return system, which is also located at the top. So here we have the same room with the same people, but instead of bringing the air in at the top, as we had before, now we're bringing the air in at a lower elevation and at a slower velocity. You'll see there's much less red and yellow in this, and most of it's blues and shades of green to show a slower air. This means two things. One, we don't need as large of a fan because we're moving less air at a lower speed overall. The initial cost of the fan can be reduced. It also means that we're burning less electricity in the long run. So displacement ventilation, as far as fan choices, gives us good upfront and long-term solutions. Here we have the temperature profile. What we get from this is that the cooler air comes in close to the ground, and convection is warming the air. You create this stratification effect. So we're only cooling about the first 6 feet or so. We don't need to cool the upper areas as much because there's no one up there. We're only concerned with the first 6 or 7 feet or so. This means that we don't have as large of a cooling load because the volume has decreased. Here we have from the EPA a demonstration of a classroom full of students. This means that we have the little pegs again, if you will, or a bit of a stretch for people, and a teacher up the front. Because the air comes in and pools at a slow velocity, it gradually rises through people heating up, through people and computers and electronics in the room heating up. This also means that the dirty air is going to be carried away as well. On this image on the left, we have a standard mixed air system where a red dye is used to indicate where contaminants, germs, bacteria, and so on are swirled around inside the room. Now, because the supply air is brought in high, it has to be brought in at a higher speed and velocity in order to stir the contents of the room. So if this person over here is coughing or there are germs over here, they get spread throughout the entire area. Now, if displacement ventilation, as shown on the right here, because we're bringing the air in at a lower elevation, the contaminants slowly rise away from people due to the convection effect again. All the hot air is rising straight away from the people without any sort of large mixing being created. Here's ASHRAE's take on displacement ventilation. And what they're getting at through their study is that if we have a mixed ventilation system doing 6 air changes per hour, it's actually more efficient and you can get the same cleaning ability through just 4 air changes with a displacement ventilation. This means that the entire room's area is being replaced once every 15 minutes with fresh air with the displacement ventilation, but we have to increase that rate to once every 10 minutes with a mixed air ventilation system in order to create the same cleanliness in the environment. EPA's study came to a similar result, showing that if you're using a displacement ventilation system, you're naturally lifting the air contaminants up and away from the breathing zone, creating a cleaner environment. So this means with displacement ventilation, as you can see in this area, we can create much higher ceilings and things of that nature without worrying about increased cooling load. Again, we're only concerned with cooling the first 6 to 7 feet because that's where the people are. That's where people are breathing the air. So if displacement ventilation is more efficient, resulting in long-term electricity savings for the customer, and you need less cooling load and a smaller fan, which saves money on equipment up front, well, what's the disadvantage? Why is no one using it? Well, the answer is you have trouble with metal ducts. And the trouble with metal ducts is where we put them. In this case, if it's installed outdoors, if it's installed in a crawl space where it's not conditioned air, it's going to rust away, and it won't be able to stand up to the environment. Here we have the inside of the duct, which is something that a customer may never see. But if you've buried it underground and encased it in concrete, sooner or later, something of this effect is going to happen. Even a stainless steel boot encased in concrete, through freeze-thaw, acidic soil conditions, sooner or later the concrete will crack and moisture and contaminants will be able to get into the ductwork and eat away at it. All right, if we can't put metal ductwork underground, well, let's put it in a crawl space. Here we don't have to worry about it because we're conditioning this area, and it's sort of an unfinished basement, if you will. Well, what's the point in saving money on utility bills and equipment if we have to add a whole other floor to the building underneath of it strictly for placing mechanical equipment? This is just kind of wasted space. Well, here's an example where they took the supply ductwork and ran it all the way down the side of the building in order to get the displacement ventilation effect. They're still bringing in that cool air closer to the ground. Well, in modern construction industry, as it has been for many years, trades are always arguing and fighting over the very limited space in ceilings. And I think the last thing we want to do is have ductwork coming down not only along the ceiling, but inside all of the interior walls where electricians and plumbers and so forth may not be used to working around it. Well, the answer is UnderDuct, made by Monoxivent. This is our fiberglass reinforced plastic ductwork. It's impervious to rust, corrosion, water leakage, etc. And we do this by a number of different methods. First, on the left picture here, you can see these 3 gentlemen installing a factory-assembled piece. When you get UnderDuct off the truck, it doesn't come in loose parts, fittings, etc. This run of, say, 17, 18 feet long, these two taps on the left side here, and this 90-degree elbow, all were done custom made in our factory. And the only joint they have to complete for this entire piece is right here next to this gentleman. Now on the right side, we can see that not only is the trunk line and the taps made of fiberglass, but also the boots. Our goal is to create an entire fiberglass system underground where there's no metal involved at all to keep things from rusting or corroding away. Here we have where it's turning up into a mechanical room. Again, because we don't have to worry about corrosion, we don't have a crawl space. That means our mechanical room can be set on grade and the fiberglass ductwork can turn up and attach to sheet metal ductwork once it's risen above the slab. Here's the Davenport Library, the pictures of which we've been looking at. And you can see on the left picture, this is what it looks like finished. Here's the register grills pumping in the supply air at a low elevation. And on the right side, we've sketched in some of our ductwork. So you get an idea of how the ductwork's traveling underneath the slab, underneath the ground. Corrosion's not a concern for us, and the customer never even realizes the ductwork's there, as it should be. Here we have another shot of the Davenport Library. Again, an excellent application for displacement ventilation. We have a high cooling load just from all of these windows that we see in the background, not to mention a vaulted ceiling of maybe 16 or 18 feet tall. We're not concerned with cooling that full 18 feet, though, as we would be with a mixed air ventilation system. With the displacement system, we're only worried about the first 6 to 7 feet. Here we have the same library. It's grand opening day. It's a hot day in the summer in Midwest and humid, and the doors are constantly being open, shut, and yet displacement ventilation is fully up to the task of keeping this room cool for everyone. We've talked a little bit about some of the simpler projects like the Davenport Library. What about something more complex? Well, this is the Dublin Performing Arts Center in Dublin, California. This is a rectangular underduct job that's double wall, pre-insulated. That means when it shows up from the factory, not only are the fittings, reducers, taps, and elbows put on to the largest extent possible for shipping limitations, but the insulation is inside as well. We have an outer layer of fiberglass, a middle layer of 1-inch polyurethane foam insulation, and an inner layer of fiberglass protecting that insulation from any moisture inside the duct or any acidic conditions outside the duct.
Okay, we have a question from one of our friends in Michigan here. It says, we have double wall duct, but do we make double wall register boots?
That's a great question. We can make double wall register boots, not a problem. We've done it before, and we're certainly willing to do it again. Now, with our standard systems, we don't tend to do double wall boots. Let me come back a little bit here. As you can see on this project, all of these boots are single wall, and you can see on the back of it, we have the pink foam insulation board. That's one of the options for insulating the boot. One of the issues with insulating the boot is these are going to come all the way to the top. And if we have, the standard on this is probably about 3/16, maybe a 1/4 inch thick. When you go to put your register grill at the top, if I have something that's 3/16 that I have to cover, that's not a big deal. But if I start getting into double wall, now I've got 2 layers of 1/4 inch fiberglass, and I've got a 1-inch insulation. This is an 1.5-inch rim all the way around. I'm going to need a larger, more expensive grill. Not only that, but the added cost of insulating the register boots doesn't tend to be all that effective because you're only insulating the air for the last, say, 2 seconds that it's going to be in the system before it's released into the occupied space. Moving back to the Dublin Performing Arts Center, here we can see the supply ductwork. It's going down at an angle because that's how the seats are going to be situated in the auditorium. So this large trunk line is going to be underneath the staircase, and these all go by every row and will pump air out from underneath people's feet. Another great application for displacement ventilation. Auditoriums have very high ceilings. We don't have to cool the entire room. The air is coming in at a slower rate. This means people are less likely to get a draft from a vent blowing straight at their feet. And the air can come in a little bit warmer because we have less of a cooling load.
We have a question from one of the reps in North Carolina. They want you to discuss field connecting manifolds to the register boots.
Okay, let's go back to the the Davenport library example again. These register boots show up as one single piece to the site. Through coordination drawings with the customer, we make sure we have the right height of boot. There's an end cap in the bottom of it, and this tap is already installed. If the job's a double wall project, this, let's say it's an 8-inch round tap, that's a pretty standard size for some of our boots. This tap will still be double wall so that it can match the size of this connection. Now, depending on how far away the trunk line is from the boot, such as in this example, we would provide a short piece of duct to run between these two, and then the fiberglass wet layup joint would be completed on either end of it. But the boot shows up as one single piece, and then once the slab is poured, the contractor can come along, cut off the excess height of the boot, and install this register group on top of it. This manifolding, like done with these boots, is a standard thing for us. We talked about it on this left image. We also have on this right image. Here's that same joint held together temporarily by a metal brace that will be removed once the fiberglass joint is cured. So these 3 taps, this reducer, all the way down to here is our next joint. So again, this is all one piece that shows up on the top. That means this, one piece. This is a second piece. And over on the left picture, this is a third piece. That's 3 pieces that the contractor picked off the truck and installed on the project. Okay, we've covered a little bit of the Davenport library and how a standard FRP job works. We've covered a little bit of the Dublin Performing Arts Center going into rectangular and double wall and larger, more complex projects. But what about something that really has high corrosion resistance value? Something that's not just ordinary dirt conditions, but something that could really attack metal or other standard ductwork. This is an image from the White Bay Cruise passenger terminal in Sydney, Australia. It's a boat terminal located on the coast. That means where this rock has been chipped away and this ductwork installed, the tide floods and ebbs twice every 24 hours, and our ductwork is coming into contact with highly corrosive sea and ocean water. Again, not a problem for us, might be an issue for any sort of metal duct that you would want to install in this area. On the left image, you can see where the ductwork runs along, all going to be undergrade once finished. And where it turns up here is where you would either take off with metal duct once you get above grade, or in this instance, it's a round table. The round tables are the seating in this, and everyone sits with their back towards the center of the circle. So if you can envision the air coming up and cooling out in a 360-degree motion. So again, with a terminal or a train terminal, airport terminal, we're not concerned with cooling the whole 20-foot vaulted ceiling we might have. And people may not even realize that there's an air conditioning system at work. Certainly you would notice that it's much cooler inside than outside, but by hiding the register grills underneath people's seats and having slower, warmer air movement, you're not going to have that draft effect that makes it quite as obvious. That finishes up this presentation on UnderDuct and how we handle displacement ventilation. I hope it's been very informative for you, and we could give you some advantages and ideas for where our UnderDuct system can help out with future projects. We also have a list of case studies on our website. If you go to fiberglass-duct.com, as shown on this slide, go under the FRP Applications tab, and you can find many photos, spotlights, etc. that our UnderDuct has been placed in.
Okay, thanks, Brian. This webinar and all previous webinars are on the Monoxivent YouTube channel. These presentations are linked off of our website. Click the Resources tab and then click Webinars. Webinars are held the last Friday of each month. Next month, our topic will center on Monoxivent source capture products. And we realize you are all busy and have tight schedules, but we certainly appreciate the time you've spent with us today.